Thank you very much. So hello everyone. Today we'll be talking about CICD for machine learning with CML. So before we continue, I'm going to reiterate that we do encourage you to post questions in the questions tab. So whenever you see a slide and I'm saying something that you don't quite understand, feel free to post a question and we'll have and we will return to those at the end of the presentation. And also, obviously, you have a chat section where you can just start like general discussions, and maybe others can help you out there. So I'm Alex Kim. I'm a solutions engineer at Iterative. It's an open source company that develops popular tools like DVC for version control and machine learning pipelines, as well as CML. And that's the one that I'll be presenting today. So before we continue, let's do the quick overview of what we'll cover today. So we'll start off with some common problems with machine learning workflows. This is kind of to set the stage for everyone and introduce what kind of problem we'll be solving and in what way. We'll talk about key assumptions about machine learning workflows that we can make. And then we'll actually introduce CML, which stands for continuous machine learning, and specifically two features related to automated reporting and infrastructure provisioning for training your models. Then we'll do a live demo of CML based off of GitLab CI/CD. And finally, we'll do a summary. So common problems that many of you, I think, if you've ever done any of machine learning, you may have encountered this or similar problems. So imagine that you're joining a team that has been working on a machine learning project for a while. So you're a newbie and you're starting your onboarding, and part of that onboarding could be reproduce the results that the team was able to achieve so far, and maybe even try and improve them. Specifically, let's imagine that you are trying to reproduce or improve model performance. So it would be a good idea for your team to version all their code in Git, and imagine that they do. So you start off by looking at the code, and then you start searching for your data. So hopefully the data set that was used to train that model is stored in some remote and shared storage that you can access. And now imagine that that project is a deep learning based project. So you actually need to provision some infrastructure because you cannot train your model on your local laptop. So you might have to log into your cloud vendor platform, whether you're using AWS, Azure, or GCP. So you start provisioning a virtual machine there. You spend some time installing GPU drivers like CUDA and attaching your data storage. And imagine you did all that and everything seems to work. So you brought your code and your data on that machine, and you're now finally ready to start the training and testing script. So hopefully that is done, and now you get your results, but the common problem is that they may not match what you thought the result would be. So you spend some time investigating whether there was a mismatch between the code version and the data version that you have, and that could take a long time, from hours to days. In the meantime, your requirements for the project may have changed, right? And even if you're successful and you were to reproduce or improve those results, you still have a question like, where do you report your results? Like, do you simply post a bunch of links and HTML files into a shared Teams Slack or like Teams channel or whatever? So there's a lot of open questions, right? Of how to go about this and whether we can streamline this process. But in order to answer that question, we first need to make some assumptions. And the assumption that I'm making in this talk, and that's a key assumption, is that machine learning workflows are not, or at least shouldn't be, fundamentally different from software engineering workflows. And we should rely on some best practices that have been developed by software engineers over the last couple of decades, right? And some of the best practices that we can borrow is, first of all, using Git repo as the source of truth. And some of you may be thinking, like, I already use Git to version my code. But versioning only your code sometimes may not be enough, right? You also need to version your configurations and also version your data. Even though we'll not be diving deep into data versioning, that's in this talk because it's a separate talk on its own, but it's also a big part of reproducibility and CICD. We also need to borrow a practice where for every potential improvement that we can make, whether additional feature or an experiment, we need to create a separate branch. So kind of following this Git flow paradigm. Also automated reporting, right? You know how software engineers tend to automate as much of their workflow as possible. Like if they push changes to their repository, they typically tend to automate execution of unit and integration tests, coverage, security scanning, whatever, right? So they don't have linting of their code so that they don't have to run all those things manually. All they need to do is work on their feature, push the code to their Git repo, and then automated tooling takes over and then provides reports for those commits that they made, right? And then all those reports eventually become parts of their merge requests or pull requests, and they allow for smoother experience when it comes to code reviews and general collaboration, right? And the question is, can we follow this paradigm, but for machine learning workflows? My argument is yes, and I'm gonna try to make it here. So what is CML? CML is an open source command line tool intended to work within CI tools, such as GitHub Actions, GitLab CI/CD, and BitBucket Cloud. It enables Git flow process for machine learning and auto reporting for pull requests and merge requests, as I mentioned earlier, as well as integration with cloud services for infrastructure provisioning. And because CML is open source, it's a public repo that lives on GitHub, and currently it has over 3,500 GitHub stars. So go ahead and check it out and give it a star as well. So right away, what do we need to do to get started with CML and CICD? So if you are using GitLab, that's what your CI workflow might look like when you're using CML. And it's very similar if you're using GitHub and GitHub Actions. It just configuration for GitHub Actions is also defined in a YAML file, in a YAML structure. It's just the syntax is slightly different, but the overall structure will look very similar. And that CI workflow will consist of typically 3 parts. In the first part, you'll install dependencies for your project and run model training. In the second part, you'll create a custom report in the form of a markdown file. And that custom report can really be anything you want. As long as you can put that information into a markdown file, that can be the report that you can use as part of your CICD and CML integration. And the third part is eventually publishing that report as a comment to your Git commit. And here's what an example report could look like. What you're seeing up on the slide is that I made a commit that changes the value of a hyperparameter of my model. And that commit triggers an automated CI run, which eventually, with the help of CML, posts a report to this commit on my behalf. And that report is what you're seeing right now is kind of almost the simplest possible report you can come up with. It only reports accuracy of my model along with a confusion matrix. but you can totally customize that report to be as complex and as informative as you want it to be. Some of you may be thinking, well, what if I have a deep learning use case and my CICD runners just don't have GPU on them? So no worries, that can also be solved with CML, and specifically with the CML Runner command. So that just simply adds kind of one additional step to our workflow, where with the CML Runner, you can provision a virtual machine in whatever cloud you choose, or even if you're running on-premise Kubernetes setup, you can use that as well. And you can specify what type of region you want to run in, the type of machine that you want to use. Like in this particular example, I'm using a G3.4x large instance on AWS. That's a machine that has a GPU on it. And then beyond that, the rest of your workflows remains the same. You still install your dependencies, run your model training, create a report, and then submit that as a comment. But now the difference is that all of those steps don't run on the runner provisioned by the CI. It runs directly on the machine in the cloud that you provisioned with the CML Runner command. And if you do that, your workflow becomes kind of a two-step workflow. First, you'll have a stage that provisions a runner in the cloud. Here we can see that I call that job as deploy job. And then once the machine is provisioned, you can run all of your model training and reporting in the second train job. And the example that you see on the right-hand side is what we'll see in the live demo later, is the example of a neural style transfer. And the report here is a bit more complex. So we can see kind of the style image that we use, the input image of an owl in the middle, and the output image where we applied the style image to our owl image and got an output. And we also see some additional info about our GPU information, right? So, and that's all, amazingly, that all becomes part of your Git history, right? We've got the commit and we've got the model output all in one place. So in short, a lot of CML commands are simply like wrappers around a bunch of Git commands. So you can obviously do all the same things, such as creating like pull requests and commits with Git commands, but CML simplifies all of that. So for example, what you're seeing right now is a kind of a high level approximation of what CML PR command does. It can create a pull request on your behalf by collecting whatever files your training script produces. So it's an approximation to commands such as git checkout, git add, commit, push, and GitHub CLI used to create pull requests. All of that can be replaced with a simple CML PR command. And why do we need those reports in the first place, right? Some of you may wonder that question. And the answer, at least from my point of view, is for improved team collaboration, because CML reports eventually become part of your code review process. That means once you made the changes that you're satisfied with, maybe you significantly improved training time, or you significantly improved models' predictive performance, right? You now can create a pull request where the automated process reports on the results of your model training. Without it, what I've seen in my experience, many people did, they would post a bunch of links as comments, some images that sort of quote unquote proves their model performance. But oftentimes that may not be sufficient, because it's very hard to track down that a particular image or a particular execution from a different experiment training framework actually corresponds to this exact commit. But because we automated this process with CICD, there's no question that the performance that we're seeing corresponds to the changes that the person has made. And if we take a step back and look at the workflow that we envision with CML, it would look like this. So this diagram comes from an excellent blog post, and I linked to the blog post at the bottom. By the way, I already see that there are some questions about whether I'll share the slides. I'll definitely do that. And at the end of the talk, I'll share the link to the Google Slides later on. So you'll be able to view them at your own pace and also access all the links that I'm listing at the bottom of the slides. So what the author of the blog post suggests, and that's what is encouraged with CML, is to have this kind of workflow where you, as a data scientist, as an ML engineer, basically anyone who works on a model, makes those improvements, pushes improvements to their Git repo, whether it's GitLab, GitHub, or BitBucket. So all three tools are supported. And then that kicks off an automated provisioning of training infrastructure, like in whatever cloud you prefer. That runs your model training, your model validation, and eventually generates a report. And that report becomes part of your Git history, and it is published as a comment to a particular Git commit or a pull request. And then you assign your team members to review your changes, and if everyone's satisfied, that eventually gets merged into whatever, like main branch, and goes into production. So you see how this workflow is fundamentally the same as what software engineers have been following for many, many years now. And we shouldn't, as machine learning practitioners, I would argue that we shouldn't reinvent the wheel, and we should just follow the best practices that have been developed before us. So now that's enough talk. Let's actually do the live demo. So what I have here and what I'm going to share with you all, actually, let me share the links to the slides before I forget. So I'm sharing it with everyone in the chat. And I'm also going to share the links to the repositories that I'm going to use for live demos. All right, now that we got that out of the way, so I have a base case here with that is going to showcase the automated reporting feature of CML without the provisioning of cloud infrastructure. We'll see that in the second example. So what I have here is a simple training script. I think it's like as simple as it really gets. You don't need to care about what training data there is, even what machine learning problem we're solving here. All you should pay attention to is that we've got some training and testing data. We have a random forest classifier with some hyperparameters defined right in the code. I know it's not the best practice, but that's not the point of a demo. So we run some training, like we fit our model, we compute some accuracy score, which we write into a metrics.txt file. And also based on the testing data, we compute the confusion matrix and we save it in a PNG file, also in the same repository. That's all there is to it. And then we have a CI configuration. So as I mentioned, it will look very similar whether you're using GitLab CI/CD, GitHub Actions, or BitBucket pipelines. They just have slightly different syntax, but the core idea still remains the same. And as I mentioned, we'll have three parts here. So we install our requirements and run our training script that I just shown you. That's the first one. In the second part, we start creating our report. That's a markdown file that I called report.md. And what I'm doing here, I'm posting my metrics, I'm posting a confusion matrix in this report, and eventually send it as a comment to my commit. So let's change some hyperparameters and see how this will work. So I'm going to edit the script. And let's say I want to increase the number of estimators by 2. I'm going to set it to 100. I'm going to do the same for depth, set it to 20. I'm going to double it. And as my commit message, I'm going to say, okay, let's do one change at a time. I'm going to say set number of estimators to 100. And then here we can either create a new branch or just commit to the same master branch. I'm going to do that. I'm going to commit my changes. And now what's going to happen is, because we have that GitLab CI configuration created, that triggers a pipeline run, which if we look into it, it actually provisions a runner, like a GitLab runner, in the form of a machine with a Docker container on it that will eventually install my dependencies, run the pipeline, etc., etc. This will take like a couple of minutes. I've already done that before, so you see I've got like a few jobs that completed. Actually, they all complete within like around a minute and a half, so it's not that long. Well, let's look at the previous commit. So the previous commit, I actually changed my requirements because I had the wrong import before. But even this change, right, it triggers a CI run, which is good because I do want to test that the end-to-end, because I could have accidentally made a typo or replaced with the wrong library. I still want to see that my model performs as I expect it would. So I get 88% accuracy, and this is my confusion matrix. If we go to, okay, so let's check our job that's running right now. Okay, so we're the step that installs our requirements. Okay, model training is done, reporting is done. Let's check out our commit. So this is the commit that finished just now. I changed number of estimators from 50 to 100, and that didn't result in significant improvements. I got about the same 88% accuracy for this model. So that's how you integrate automated reporting into your Gitflow process. So that's one example. The next example is going to be slightly more complicated. And as I mentioned, we'll look into a neural style transfer and what neural style transfer is, right? So you have an input image, you provide some style image, and the output is basically something that resembles an input image, but stylized to the style of your second image. So, and that's the second repository that I'm going to show you here. The actual code that does neural style transfer is not important in this case. What is important is that we parameterized style reference image. So I have a few images that I've prepared in the images folder over here, right there. We can take a look at them. So this is one style image, this is another, and this is the third one. And the input image that we have is just an image of an owl over here. So here we have our CI script. As I mentioned, now when we want to do some, when we want to run models that require a GPU, all we have to do is add one more step with the CML runner. So here I'm saying I want to provision a runner on AWS in this region. This is my EC2 type. This is how much disk space I'm asking for. This is probably an overkill for this problem, but still. And then in the script, I have some setup. I'm installing like ImageMagick. I'm installing Python requirements. And then most of it is just kind of concatenating input image, style image, and the output together so that I can publish it in the report. And then also, I do want to see which GPU was used to run my training. In case I change the type of machine I'm using, I still want to see which GPU was used and how much time it took. So this is my CI configuration. And now let's change the style image that is on this commit is Kandinsky composition. So let's pick a different one. So I'm going to edit this file and I'm going to pick this. I'm going to pick this image instead. And all I have to do is simply replace the name. And the comment here is going to be try as style image. And I'm going to commit my changes. And now if we look at our pipelines, that triggers another CI run, but this time CI run consists of two steps. The one that provisions my machine and the one that's going to do the perform actual style transfer and create a report. So that's going to take more time because now there's cloud involved and infrastructure provisioning. So that overall takes about like 10 to 12 minutes. We can look at the previous run again, where I switched one style image for this Kandinsky image. And this is the report that got published automatically. So we've got, this is the style image, this is the input image, and we've got the combined result on the right-hand side. And this is the GPU information. I can tell that I'm running on Tesla M60 and my CUDA version and so on and so forth. If I wanted to, this would become part of my pull request. My teammates could comment on the changes that I've made and results that I was able to achieve. So that's it for the live demo. Let's switch to a summary slide, and then we'll do a quick Q&A. So for summary, the key assumption that I've made is that machine learning workflows are not and should not be different from, like fundamentally different from software engineering workflows. And that means that model training should be part of the CICD process with automated reporting where we can see the results that the model was able to achieve. We should have easy infrastructure provisioning and deprovisioning. And this is the part that I actually kind of looked over during the live demo, is that when we provision a runner, like a machine in the cloud, CML automatically takes care of deprovisioning that machine, kind of destroying it so that you don't have to pay for it once the training is done, right? So that's very cool. So you'll never encounter this surprising bill that you left the machine on for a couple hours. And eventually, once you have all of that in place, that hopefully will result in improved team collaboration, because now reporting becomes part of your code review process. So that's all I had. Thank you for your attention, and let's start with the questions. Wow, there's a few questions over there. Okay, so let's start from the top. There's some questions about certification of attendance. I don't think I can answer that. Maybe Deepti can answer that in the chat. Let me see if I can find some CML related questions. I'm wondering if CML CLI parameters support provisioning specifically to Google. Yes, I think I had one of the slides on that. So CML supports AWS, Azure, Google Cloud Platform, and Kubernetes. Does CML support other Git repo hosts like BitBucket? So yes, CML can support any Git repo host, but it's designed to integrate with BitBucket pipelines, GitHub Actions, and GitLab CI/CD. If you're using some other CI/CD solutions such as Azure DevOps or Circle CI, then there are issues in the CML repo that were created please go ahead and upvote a relevant issue and add your comment, because if there is enough interest in other CI tools, our team may prioritize it accordingly, and CML may come to your favorite CI tool fairly soon. Another question, can you send a report as an artifact to Git? I'm not sure what you mean. So right now, reports work as a comment to Git commits or pull requests. But if you want to send it as you can actually create a commit, right, from inside your CI job and simply run like git add report.md and add it to your, create a new commit with that report. That's totally possible. Can we run GPU training on a local box and include the report in our commit? That's a very good question, and that's totally possible. Even going to take a small detour to CML documentation. By the way, CML documentation lives on cml.dev. So if we go into documentation, there's a section for self-hosted runners. And the first part of it is assume self-hosted, meaning like Azure, AWS, GCP, or Kubernetes. But you have a local desktop like on-prem. There's a section somewhere down here. I think, yes, so called on-premise local runners. Let me send this link as well. So all you have to do is run a command with CML Runner launch, but you do need to provision like a access token on that in your repository. And what will happen is this command will launch a Docker container, kind of listen to events in your repository, launch a Docker container on your local box whenever you trigger a CI run. But that's totally possible. All right, another question. Is automation of PR creation really saves time, maybe a few minutes, but manually doing it also provides advantage of reviewing once again before pushing anything? Do you think automation is really that important? Well, it depends on the type of product or service that you work on. In some cases where, like especially if you're working on a proof of concept, automation may not be important at all, right? Speed can be important, that you iterate very, very quickly. But I would argue if you work in a large enterprise corporation where reproducibility and ability to kind of report and prove the result that you made is important, it may be a requirement for you to actually merge stuff into like a main branch, then you don't really have many options. And the fact that you spend a couple of more, like a few additional minutes running a CI pipeline may not be kind of that big of a deal if you work kind of within those constraints. So to answer your question, do you think automation is really that important? Unfortunately, my answer is that depends, but I have seen situations where not only is that important, but it becomes kind of critical. Is it a type of a data pipeline? Well, not really. It's not a type of a pipeline. As I said, there are two key features that CML brings to the table. It's allowing you to easily report on the results of your ML pipeline and also help you run your pipeline faster, or just allow you to run your pipeline at all with infrastructure provisioning. Because GitLab CI/CD, for example, they do not provide you with GPU runners. So either this neural style transfer use case would fail in GitLab CI Runner, or it would take a lot longer to run. Okay, next question. If we are to follow standard software engineering practices, then apart from automation of a few steps, what's the real advantage of introduction of a new tool, CML? Can we follow standard practices without CML? Well, of course, the idea that you would have some unit integration tests as part of your code that you would use feature branches when you want to like introduce improvements to your model. All of that we kind of already covered, specifically the part that I was covering here, because machine learning workflows, it does introduce some additional requirements, right? And one requirement is we have model that we cannot inspect kind of all the coefficients of the model, but we can inspect its overall performance in the form of metrics. And the second thing is sometimes, and in many cases, especially if you're dealing with unstructured data, you kind of have to use deep learning for like NLP tasks or computer vision tasks, right? As I said, like you kind of have to have a way to provision more powerful infrastructure. So if you already, like as a machine learning practitioner, I would say if you're following a few software engineering best practices, you're kind of already in a good shape, especially compared to whatever the median in the industry is. But you can, there's always an opportunity to improve. And I think CML, introduction of CML into your CI/CD pipelines could be one of those things. There was also a question about using CICD in Circle CI, so I think I answered that earlier. Oh, there was another good question of how do you configure access to AWS resources? Right, that's another thing that I kind of didn't really spend time addressing, but as part of, if you're running on GitLab CI/CD, if you go into settings and CI/CD, there is a section to configure variables. And I have set these AWS access key, AWS secret access key, and repo token in here. If you're running on GitHub Actions, there's a section, let me open like some random repository here. So on GitHub Actions, in the security secrets action section, there is a similar thing where you can set the credentials used by your CI/CD tool. Another question, what if I submit multiple changes near each other, like a dozen? How can get an overview of which ones get best accuracy? If I'm going to commit individually, that's a bit impractical. So there's different ways, right? You can approach this. You can introduce kind of hyperparameter tuning as part of your CI/CD run, and then basically means that you'll have some kind of commit that will where you can configure your hyperparameter tuning strategy, commit those to Git, and this will trigger a run. Alternatively, if you want to run multiple experiments in parallel, you could simply create different branches, right? There could be a branch where you try a different model architecture. There could be a branch where you try different data preprocessing techniques. So use different branches, and every time you commit to a separate branch, it triggers an experiment. So that kind of depends on how you want to approach this. And then when you're done, like you obviously a good practice to, if you merge your branch into a, like whatever main branch, you kind of get rid of it, get rid of your feature branch so that you don't pollute your Git history over time. Next question, how's the data coming to the cloud machine? I imagine that especially for deep learning, there's a batch way so your model can start training before a complete data set is available. Are there such possibilities? Well, if you're talking about streaming data, that would be kind of up to you to decide how do you want to configure it. Obviously, you will have to configure access to your CICD runner to access that, whatever streaming your data into your model. But that's, I think, is a less common situation, a more common situation where you have some data set that lives in some remote storage. And the answer here is you can use CML in combination with DVC. So for those of you who are not familiar with DVC, it's an open source tool for data versioning. And it complements CML really, really well. So all you have to do, actually, let's switch to a front page here. And there's actually a separate tab that shows you how you would introduce DVC data versioning within your CML pipeline. So all you'll have to do is add DVC pool and imagine that your data lives in the data directory in your repository. You'll run DVC pull data, and DVC will pull data that a specific version of your data, not just any version, but very specific one that corresponds to that commit. And then the rest of it is the same. You'll run your, you install your requirements, you run your DVC pipeline that will run model training, evaluation, and so forth. And then the rest of it is the same, where you can create a markdown report and post it as part of your Git history. And we can see that example over here. So there's another CML report with metrics. We can see the changes that were made and so on. So yeah, by combining DVC and CML, you actually get kind of the best of both worlds, reproducibility from the kind of infrastructure and dependency point of view, as well as reproducibility of like from the data versioning point of view. Where is the trained model stored and how is it versioned? That's actually very much related to a previous question, because you can also use DVC to version your model and not just data. So if your model is like very small, like a scikit-learn random forest type of model that I shown you earlier, you may be totally fine with versioning your model directly in your Git repo, right? Because the model is going to be like what, maybe a couple of megabytes at most, so that could be fine. But if you're doing deep learning, that's not an option, because deep learning models can be huge. So you could use DVC to version a specific model of your data. And the way it will look like, maybe I have another example. Well, we don't really have time to go through like DVC right now, because that's not what this presentation is about. But the idea is you pull your data, you run your training. At the end of it, you run DVC push command to push your model to some remote storage. And then you can also create a pull request automatically, as I shown you with CML, with the CML PR command. Maybe there's a, okay, we don't have that example over here, but you can basically commit all the files at the end of the pipeline run and create a pull request out of that. Hopefully I answered that question. So usually training is done in notebooks unless for neural network on huge data, which is done in Python scripts. Do you think CML is useful for notebook training? Yeah, I don't see why not. I mean, there are tools that allow you to run notebooks through through command line, right? There is a paper mill. It's an open source tool that that I think came out of from Netflix, right? So Netflix is heavily relies on this tool, and the idea is, let's take a look at the example. Right, here's the example that I'm looking at. Within your CICD, you will simply say paper mill, point it to your notebook, and then to the output notebook. The example that they have here is where you output directly to a bucket, but it doesn't have to be a bucket. It can be simply a local notebook that you call output, and then you can optionally provide some parameters. But that's the way you can integrate execution of your Jupyter notebook as part of your CI/CD. And then you can commit the output notebook back into your Git history, so you'll see the result of your notebook run as part of your Git history. Yeah, I hope that answers that question. So there was another question about other than GitLab. Yeah, so I can reiterate that CML also supports GitHub and BitBucket. Another good question, does CML support runners running on Spot instances? And the answer is yes. If we go into the documentation and specifically look at the CML Runner command, scroll down, and there is a option to say CloudSpot. So you enable that, and then you can also provide CloudSpot price, meaning that Spot instance will only be provisioned if whatever spot price at that moment, if it's lower than this maximum that you set. So, and for those of you who are not aware, spot instances are basically instances where price for machines fluctuates based on the demand. And most of the time, it's significantly lower than on-demand pricing. In some cases, you can save up to 90% of your computing costs. But the downside is that that instance can be taken away from you in any moment. So if running CICD execution of, if you're not expecting your CICD pipelines to run sort of 100% of the time, and you can tolerate occasional failures, using this CloudSpot configurations can save you a lot of money. Can CML take care of other aspects of ML pipeline aside from Git commands and machine provisioning, such as data pre-processing, data cleaning, etc.? So not, because that's not what CML was designed to do. It's really a tool that was designed to not to be used when you develop, right? You don't run CML in your whatever IDE. You run CML inside your CI tool. But to answer your question for data pre-processing, data cleaning, so it sounds like you're really asking about machine learning pipelines. So that's where DVC really comes in, both with its data versioning and its pipeline capabilities. So let me drop a link to DVC in the chat for those of you who are not familiar with it. And again, as I mentioned earlier, DVC integrates really well with CML. Another question, I did not understand, how do we install CML in a Git repository? That's a good question. You didn't understand it because I didn't cover it very well. So the way you use it is this line over here. You basically tell which Docker container, which Docker image to use on your runner. So when GitLab Runner provisions a machine, it uses some Docker images. It can be like basically an empty Ubuntu image, but this one, this image already has like CML and DVC installed on it. So everything, like when I run CML command here, it already exists inside that image. And it's the same way in GitHub Actions or BitBucket pipelines. Does it support Databricks? What are the advantages over MLflow? So CML is not an experiment tracking tool like MLflow. It's really a tool to integrate machine learning as part of CICD. So it doesn't really, they don't really overlap, I guess, in comparison. It's like to some degree, it is a reporting tool, right? But it allows you to do your experimentation in a more, I guess, rigorous and disciplined way. Because on any commit that I click on, right, over here, I see the change and I immediately see the results. Maybe it's can take a little bit longer than you would experiment using other tools like MLflow. But also one of the pain points that I've had with MLflow and other similar ML tracking tools is that sometimes you run so many experiments and you don't actually, like you change a bunch of code, like your model architecture, what models you tried, but then unless you explicitly log those changes, they kind of get lost. So you end up with many, many experiments in an MLflow dashboard that have different model performance, but there's no way for you to actually track down the changes that you've made. And that was kind of the biggest deficiency that at least I've seen in this type of tools. Another question, as code and models get and dependencies get bigger, Docker containers also get bigger. This can affect CI automation because it needs to pull down layers each time, which can take a long time per CI action. How do you optimize for this? Right, so if your dependencies, like two things, if your dependencies take a long time to get installed and you're not planning to change them frequently, it may be a good idea to create your own Docker image that when CI pipeline gets started, it just pulls that pre-built image and runs it, and it can save you some time. Specifically, the line that I'm talking about, like an example could be this one, but it's a simplified example. Before we install requirements, we could have, actually, let's look at another example in this cloud use case over here. So you see, I have like some apt update, upgrade, and I'm running CUDA driver installation. I'm installing ImageMagick, and then I'm installing pip requirements. I haven't looked at how much time this takes, but it could easily take a few minutes, right? In some cases, this kind of installation can take more. So it might make sense to basically base your image off of this one, and then create your own Docker image where you already do that installation, and then refer to your customized image in here, and then run the rest of the training code after that. So that's where you can save some time, in my opinion. How CICD can work in ML Android application, like if we change our model and input data type. That's a good question. Unfortunately, I don't have much experience with kind of mobile, like using machine learning models as part of like edge device deployment to like mobile phones. I would imagine that you would have, in addition to like model training and reporting, you would also have additional checks like integration tests where you actually verify that because you'll have to do some model conversion. I presume you cannot just use model as is. So you'll have to do some model conversion, maybe with tools like ONNX or whatever, and then verify that the performance that you get with the model before the conversion, after the conversion is the same. That could be part of the same workflow or a separate workflow that gets triggered. So I know it's kind of not a very detailed answer, but that's because as I said, I have limited experience with mobile applications. Why choosing DVC rather than ML Flow? Well, that kind of depends, right? There's many other tools that allow you to create machine learning pipelines and experiment tracking. I can tell you about the differences, and then you can decide which one you would choose. So the primary difference between DVC pipelines and other solutions is that DVC has very tight integration with Git. Like data versioning in DVC is based on Git. ML pipelines are also based on Git integration. So if your team is already kind of following Git flow practices, or at least plans to, then it may be worth for you to look into DVC. If you're mostly working in like Jupyter notebooks and you do version stuff in Git, but you don't actually use different branches, maybe you commit everything directly into it, then DVC may not be as attractive to you. So it's kind of depends on the use case. Right, more questions. So can you have CML PR prevent a merge based on data model performance metric? For example, this PR cannot be merged because accuracy of model decreased or something like that. Well, preventing a merge, that's probably, you could configure your CICD on some certain triggers. To be honest, I don't have any experience with that. But one thing that you could do is you could have an if clause before you run CML PR command, right? Basically, inside your CI pipeline, you'll have like an if whatever number is greater than some threshold performance, then you run CML PR. Alternatively, you don't create a PR, right? So basically, you solve this problem even before you create the PR. There won't be a PR unless the model performance is greater than a certain threshold. Another question, what the advantages you see of CML compared to Terraform? So they're not necessarily kind of competing tools because CML is based on Terraform. Specifically, it's based on this tool called Terraform Provider Iterative, or TPI. So let me see, iterative TPI GitHub. Let's find it here. So let me post a link. So CML is basically an abstraction of Terraform. So it's more user-friendly because you don't have to know Terraform in order to use CML. Okay, then another person is asking to resend some links. I think Dipti already done that, so thank you. And another question about Circle CI. What are things CML can do that Circle CI can't? Well, they're not competing tools. CML is designed to be integrated with CI tools. And as I mentioned, at the moment, Circle CI is not supported by CML. How do you develop CML scripts so they don't fail on the cloud so that feedback loop is quick? That's a very good question, a very common one. Well, one thing is that you can actually install CML on a local machine with NPM. So there's like more in the documentation how you would install and try it locally. Alternatively, there's tools that open source tools that allow you to kind of mimic your CI tools, but locally. I know that there's one for GitHub Actions called Act. Let's see if we can find it. Yeah, there you go. As it says in the title, run your GitHub Actions locally. So if you're, and I'm sure there are similar tools exist for GitLab CI/CD or maybe BitBucket pipelines. Okay, so thank you very much for a lot of questions, a lot of very good questions. I don't think I've ever had that many questions in the presentation that I've delivered this year. So thank you for paying attention and asking good and very interesting questions. We are right on top of the hour, so perfectly executed timing, I would say. And thank you very much, and hit me up on GitHub, LinkedIn if you have any questions. Thank you.